So this is a quick update of my Cessna 172 project, and this is what it basically looks like. As you can see, I could turn the knobs and change the frequencies and put the standby active, and the same thing for the nav, and same thing, no problem. I've built the casing using my 3D printer. I had to do it in two parts because my printer isn't big enough to print the whole thing. So I had to print the bottom part, and then I printed the top part. And of course I printed each of the panels, such as the unfinished autopilot panel, and the this is my transponder panel. So each panel slips right into its spot, and this is a future audio control panel, and this is the ADF, which I will be changing the 6-digit display to a 4-digit because that's all I need. And when I turn on the transponder, and it activates. Also, there's an LED which is not complete yet, but it will flash every time the radar passes in front of it. I've also added the two displays here. This one shows the magnetic compass, because to reset the gyroscopes, it's very difficult to actually get it centered properly. So at least I have a digital backup. Also, the barometric pressure display. So if I change that, at least I'll be able to see it directly instead of trying to figure it out on a small screen like this. And of course, you could barely see what direction we're pointing in. So that's basically what the bottom part is. This is an extra, so if I decide to add an instrument, I could do that. And the rest is piece by piece. Now this part here is my main panel. It's the main bus, basically. My Arduino is right here, and this is the multiplexer, which displays all of the these displays here. It controls all of these through this one display, and it's going through these 20-pin cable, and this is the S0 through S3, and the positive and the negative signals. This is a 3-amp power supply because the Arduino just isn't good enough to supply all the power to all those displays and other instruments which will be added on later. And this is the multiplexer that's going to be used for all the analog signals, which includes the volume controls for the audio, as well as the throttle, mixture, and other analog signals that I need. So everything will go through here. Now this is the main panel here, and it has all the connectors needed, but this was designed for version 10, which I am now on version 11, and I'll explain why. So these connectors down there are for the audio, for the instrument panel, the switches, switch panel 1, switch panel 2, and the analog signals. These are the MAX 7219, which I've discovered a problem, and I believe it's with SimVim, because every time an LED is pulsed from the radar return, it causes the segments in the max to disappear. Here we have the DM13A, which is your LED drivers. And again, this is the multiplexer for all the 7-segment displays. These are extra pins coming from the Arduino, so if I need to add signals later, I could just tie into those pins directly. These are extra connectors on the bottom, and so I could actually create different jumpers, 20 pins, up to 20 pins. I could use regular, there we go, regular 2 pins, 4 pins, 10 pins if I need to. These are the signals going in, and this is the connector that would be tied into there, as well as a secondary one if I need to. If I need a circuit that will actually need S0 and S through S3, then I have those two on the right, and so I could just tie in the signal to the X here, so that I could tie in the signal from anywhere and use that for a multiplexer or whatever else I need. These are the resistors. These are the LED outputs. So I have up to 16 of them. One of them is already on the 40-pin bus. And so these are for the actual instruments that I'm going to use. For example, the display to show what flap position is in using a servo, and others that are used for different analog display outs. Now this is what allowed me to create version 11. It's a backplane, and as you saw it before, it ties in all the signals into separate connectors. They're already predefined, so all I needed to do was take a panel and mount the connectors onto this universal interface board, which is in each panel, and it ties in directly to the connectors on this board in the back. So I don't have to run so many wires, and it makes it far easier to set up a connection to all the panels that are in my system. So this is the preliminary video showing what I've been doing for the past year. I have slacked off for a while because I was into other things. But eventually all of this will be mounted in an aluminum faceplate panel, and other devices will be attached to